Hello, good morning, friends. I just start magnetic particle level 3 because it is necessary who passed clear my basic level 3 exam. So let them pass for magnetic. The principle of magnetic particle testing. Magnetic particle testing can detect both production discontinuities such as seams, laps, grinding cracks, and quenching cracks, and in-service damage such as fatigue and overload cracks, and used for ferromagnetic materials. Only for ferromagnetic materials. Magnetic particle testing consists of magnetization of the test object followed by application of magnetic particle and interpretation of patterns formed by these particles as they are attracted by magnetic leakage field. Magnetic particle testing can reveal surface discontinuities, including those too small, too tight to be seen with unaided eye. Magnetic particle test can also reveal discontinuities that are slightly below the surface. The ability to locate subsurface discontinuities has limits determined by discontinuity depth, size, type, shape, the strength of the applied field, and the type of current used, which I marked. You have to see very carefully. Sometimes the questions will come from there only. Magnetic particle testing cannot be used for non-magnetic materials. The Earth itself can be considered as a bar magnet because of its two poles. Because of its stable magnetic field due to rotation, movement, and molten iron core. Magnetic fields. So this is the magnetic field for a bar magnet surrounding the bar magnet. The magnetic field exists within and around the permanent magnet or within the around a conductor carrying an electric current. The magnetic field surround a permanent bar magnet has polarity, but the magnetic field surrounding a conductor doesn't have polarity. Some type of magnetic fields may be contained entirely within the ferromagnetic object. The magnetic field surrounding the bar magnet is shown in figure 1. Those are circular magnetism. Magnetic fields may be contained entirely within the ferromagnetic object. This permanent retaining magnetism more or less permanently, temporary retaining magnetism only as long as magnetizing force or current is being applied. So magnetic attraction, the same pole repel, different pole attract. Direction of discontinuities. All the forces act to align atomically small zones called domains in the direction. This direction is arbitrarily termed as north to south. Law of magnetism. The interchange action between atoms and alignment of magnetic domains cause increased flux density. As the magnetizing force increases, the aligned domain increases in the volumetric step. The incremental increase is detectable and is often referred to as the Bragg-Johnson effect. They may ask flux density, Bragg-Johnson effect. When all the domains in a material are aligned, the material is said to be magnetically saturated. They can ask magnetically saturated. So paramagnetic, they will ask all these things. Weakly attracted magnetic material not normally tested by magnetic particle testing. Weakly, very weakly. Ferromagnetic, which is tested by magnetic material particle testing. Materials having high magnetic permeability greater than 100, such as nickel, iron, cobalt, and many isotopes with higher atomic number, uranium-92, such as gadolinium. So diamagnetic materials that are weakly repelled by magnetic field. This is weakly repelled, that is dia, and para is weakly attracted. This kind of magnetism is often used to locate buried and hidden conductors. Non-magnetic materials. This classification include materials are not strongly attracted to or repelled by the magnetic field. Non-ferromagnetic. This encompasses the majority of metal and other non-metallic materials caused by their low degree of magnetic permeability. Because of the inability to react with magnetic field, inspection using the magnetic particle test method cannot be performed on this material. Non-ferromagnetic materials, if non-porous, may be inspected using alternative test methods such as liquid penetrant testing. The characteristic of magnetic field. These lines of force called magnetic flux never cross. Generally, they seek the path of least magnetic resistance, are most densely packed at the pole of the magnet, flow from north to south poles outside the magnet. So this is important. The flow. So these two sometimes they ask. So each one is really important. But this is most important. This seek the path of least magnetic resistance are most densely packed at the poles of a magnet, flow from north to south pole outside the magnet, and south to north pole within the magnet. So this is most important. Do not enter or leave at the center of the magnetic field. Within the magnet, south to north. So it is coming from south to north, but in outside is north to south. Yeah. Poles in straight bars also broken material, broken magnet. So in the circular magnet, it is inside, magnetic field is entirely within this, no external poles, but here magnetic poles, they attract the magnetic field. So magnetic poles will lift and draw a nail to magnet. Personal qualification. This really no need, but still I will tell. SNDTC 1A, level 1 non-destructive testing and working under direct supervision of level 2 and level 3. So this maybe sometimes they ask, he cannot, level 1 cannot work independently. Though nowadays they can, but still they here they under the guidance or supervision. He can perform many things, but specific task, specific interpretation, specific technique, all these things are there. Still, he has to working under the direct supervision or guidance, like that. So level 1, level 2, level 3 magnetic particle testing technicians should be qualified through specific and practical examination based on requirements of applicable code. The text provides the overview, the fundamental theory of magnetism, magnetic flux, type of particle fields, principle of electrical induced magnetic magnetizing current, testing media, equipment, process controls, the basic principles and method of demagnetization, reporting of magnetic particle test. Effect of discontinuities on material. A leakage field at or air gap in a longitudinally magnetized test object is shown in figure. So this disruption is produced by alignment of magnetic domains in the stretched metal crack site. For this reason, because one side of this there is a it is coming south to north, so it will form a north, here form a south. It will just pass through this. For this reason, cracks in the formation state are highly detectable, normally produce sharp, well-defined indications. Open cracks that have been subjected to large thermal, chemical, mechanical forces have had their magnetic field disruption characteristics greatly or entirely reduced and may not be detectable using magnetic particle testing. For high detectability forming surface cracks, magnetic particle testing uses induced alternating magnetic field technique as the primary method to test in-service ferromagnetic objects. Wet alternating current fluorescent technique is generally produce highest sensitivity obtainable. So this is most important. Scratches, unlike cracks, exhibit metal grain plastic tearing that lowers the ability of this discontinuity to repeatedly attract magnetic field in a uniform manner in a given scratch size. Very deep scratches should be evaluated by their visual characteristics rather than their relative magnetic particle indication sizing. Subsurface discontinuity. In general, the magnetic image is very broad and fuzzy. Most important. The changes in test object thickness and holes from the opposite side may produce misleading indications. Magnetization method. Required magnetizing current duration when to apply particles, alloys, shape, magnetic condition of the test object, type of magnetizing current, detects direction of magnetic field, sequence of operation, values of flux density, circular or longitudinal. There's so many things there. So let us see. Circular fields, direct magnetization, passing magnetizing current directly through the test object using a headset or prods. Indirect magnetization, passing current through a conductor surrounded by the test object. In direct magnetization, the magnetic field will be uniform throughout the length and test object that the test object is uniform in all respect. Test object is placed between two heads on a bench unit. Direct method of inducing circular field is one by the use of prods shown in figure 1b. So this is a prod circular magnetization. If current is passing through, there is a right hand rule. The direction of current and direction of magnetic field on the direction of your fingers. That if the thumb is in the direction of current, the magnetic flux lines will be in the direction of your fingers. That you have to remember. And now let us see. The direct magnetization, the magnetic field will be uniform throughout the length of the test object. Test object is placed between two heads on a bench unit. Direct method of inducing a circular field is by use of prods, and field between the prods and somehow distorted by interaction of two fields. Prod magnetization is most effective when the prods are spaced 6 to 8 inches, 150 to 200 mm apart. So 3 inches you cannot do. It is coming next. Indirect magnetization, indirect induction of a circular field. Central conductor method or prod method. So this is coming. Indirect magnetization. Central conductor also eliminate possibility of test object being burned by the flow of excess current or poor contact being made with the heads of the prod tips or the copper heads of the bench unit. Uniform shape, copper rod external field is uniform, the same radial point along the length of the conductor. If the conductor has a uniform shape, example copper rod, the density of external field is uniform at the same radial point along the length of the conductor. Magnetic field strongest at the surface of conductor and zero at the and decreases at the distance from the conductor increases. So on the upper side. But if you go for the conductor, it is zero at the center. And then it is on the surface of conductor, it is high. And if you go for the magnetizing, means the testing materials, so that here is telling the decrease as the distance from the conductor increases. This medium, the magnetic testing medium, and this is the central conductor. So with the increase of the distance, it will just increase. It will decrease the magnetic field decreases with the distance of the conductor increases. Direction of magnetic field lines is 90-degree angle to the current in the conductor. Right hand rule shown in the figure. Right hand with the thumb pointing to the direction of current flow. The fingers then point the direction of the lines of force. So this one is the right hand rule. Fingers in the direction of current. And then the thumb is in the direction of current and your fingers is in the direction of magnetic field. The current flow in the conductor creates circular lines of force, that is circular magnetic field. Field is right angle to the conductor as shown. where current flow through the test object magnetization is said to be circular. Our use of alternating currents welt fluorescent particle takes one of the most sensitive magnetic particle testing. Skin effect. The alternating current is concentrated on the exterior surface of the test object. Direct current half-wave direct current test completed before the alternating current test increases the probability of detection of both surface and subsurface discontinuities. Direct current or half-wave direct current test completed before the alternating current test. So this is important. Increases the probability of detection of both surface and subsurface discontinuities. As the frequency of the magnetization current increases, the depth of penetration decreases. The frequency of current, it will never decrease as such because it is maybe some bench units have something like that, but frequency is somewhere 50 and somewhere 60. So it is constant throughout these countries. The alternating current level is greater than the direct current. The test object can be effectively demagnetized by reducing the alternating current to zero at the end of observation stage of test cycle. So to demagnetize, you have to go for higher, greater than the direct current alternating current level. Then only you can demagnetize. Magnetic field in a long solid hollow cylinder fixed at the outside diameter surface for both magnetic and non-magnetic test object. From here, magnetic field obeys the inverse square law and decreases by inverse square law of the distance from the surface around the solid and hollow magnetic conductors. Figure 3.4. Inducing magnetic fields and test objects. The magnetic field density varies with shape of the test object. Tubular objects may be tested using central conductor. An alternate method to wrap a coil through long test object is rotate the test object. So tubular objects may be tested using central conductor. Several wrap setting setups may be required for an effective test. Gears and other machined objects often have holes, keyways, or gear teeth that can effectively tested by magnetic particle means. Several setups may be required that include different current type, strength, and direction as well as test object rotation. So this is the magnetic field. Field distribution in and around a solid magnetic conductor when carrying direct or alternating solid line current. So see, this is a ferromagnetic substance, not solid magnetic conductor. If non-magnetic, it will be different. So if DC, it is just the dotted line if you see. So DC will go for dotted line. You start at 0 for the center and then the surface, it will become maximum mu h, B equal to mu h. So mu times the strength. So after this will suddenly down and then a parabolic curve. So here it is 0 at the inner radius. And these are if directly contacted with the current. It is not with central conductor and all. This is directly contact. If current is passing through directly through this and directly through this. This is the field distribution. DC is outside the straight line and AC will go something like the skin effect. Just at the skin. Then if it is Non-ferrous metal, it would have finished here. It will not go for mu x, it will just mu h, it will go for h, that's all. Because it is going, B is mu h, mu times the h, permeability into field strength. B is the field strength, the field, sorry, means the strength. H, which is the magnetic strength. This is the field strength. Deep holes and sharp gear teeth may be tested using magnetic particles suspended in a self-curing magnetic rubber. Here the test object residual field must be high and current must be applied during the total curing time of rubber. So what they are testing? Deep holes and sharp gear teeth. They can use magnetic particles suspended in a self-curing magnetic rubber. And when rubber is carefully peeled away, the magnetic indication may be observed in the rubber. The use of fluorescent magnetic particle enhances the method. A continuously applied current, okay, till this cure time of the rubber through. It is not stopped. When rubber is cured, then you remove the field. Current must be applied during the total cure time of the rubber. So equipment for inducing circular fields, contact plates or copper plates that came in contact with the test object or a central conductor, wet bath technique. Used in wet bath techniques, contact plates are found in specialized magnetic particle equipment called wet horizontal bench machines. Prods are specialized form of small contact plates. Prods are firmly placed against the surface to be magnetized. A circular magnetic field is set up around the prod. Wet horizontal bench machines are equipped with prods for irregularly shaped test objects. Portable magnetic particle machines with alternating current between 1000 ampere and 2000 ampere are the most common type of prod testing equipment. So this may be a question sometimes. The typical horizontal magnetic particle bench testing discontinuities commonly discovered by circular field is generally surface breaking irregularities with crack, having highest probability of detection for all current modes. Near surface cracks and cracks under coating and galvanized are commonly detected. The coating is not too thick. So typically longitudinal fields are induced in the test object by coils. Magnetic field in the produced by current flow in coil. This long non-magnetic conductor wrapped around the test object. The magnetic test field is greatest at the surface line of the coil. Thus, the test object should be placed near or inside surface of the wrapped coil. Surface means inner surface for coil. Field strength and direction. Coils may require several wraps of coil build up enough magnetic flux density for proper testing. So because of this right hand rule, it will go. If you see this, so it is turning like this, but when it rotate, then it will turn in like this. So the force total resultant force is like this. So inside south to north. So one side south, then another side become north. This solenoid coil. Field strength and direction. Coil may be require several reps of the coil to build up enough magnetic flux density for proper testing. Yoke may be used to magnetize a test object longitudinally, referred to as a longitudinal field and rotation to the yoke. These are longitudinal, not circular current. In magnetic, really current, magnetic current, magnetization, that is longitudinal field only. So the yoke may also be used to magnetize a test object transversely by changing the direction of the legs. Field produced by using central conductor circular, but here it is longitudinal. Essentially, a yoke is a temporary horseshoe magnet made of soft, low retentivity iron that is magnetized by a small coil wound around its horizontal bar. The magnetic particles are applied sparingly in the area between the poles. Indication on the surface discontinuities are produced and can be detected. The direct current DC yoke detects subsurface discontinuities. Discontinuities detected by longitudinal fields, commonly discovered by longitudinal field transverse discontinuities. Transverse discontinuities are oriented perpendicular to the major axis of the test object. So anything right angle to the flux lines. So these are transverse discontinuities. Those are radial discontinuities with circular. So the two things are different. Both alternating current and direct current techniques may be used. Advantages of longitudinal magnetization. Easy to demagnetize since the direction of magnetization is known due to pole presence. Appearances in the longitudinally magnetized test object of opposite magnetic poles, north and south, at the extreme ends of the part, making easier to understand the magnetization. No electric contact with the part is necessary. Longitudinal magnetization is easily obtainable by wrapping the coils. Disadvantage: no detection of longitudinal discontinuities. The leakage flux is weakened. Leakage flux is weakened by pole ends are not parallel to the part surface. Time-consuming technique for use on certain test objects such as plates. Schematic repositioning of test object is required in order to detect random discontinuities. Multi-direction magnetization. Typical uses of multi-direction magnetization are large castings, high volume small test objects with automatic detectors, critical test objects such as aircraft landing gear. This is like you can rotate the magnetizing field, multi-direction. In the XYZ direction, that is what multi-direction. Weight particles. For weight test using true residual technique, smaller particles may accumulate faster, producing an indication. For weight test, larger rounded particles may produce an indication faster under continuous magnetization technique. Colors and backgrounds should be selected to provide optimum contrast and viewed by the technician. So the white contrast you are using. Wet particles including oil-based visible fluorescent and water-based visible fluorescent fit various testing requirements and environments. When the assignment is find very fine surface cracks, the wet method is superior no matter the form magnetizing current is used. So this method is complete coverage for all size and shapes. Dry particles. For dry test, very fine particles are moved slowly in air, may produce better visible buildup. For vertical and overhead conditions, using yoke magnetization. For dry magnetic particle testing, the use of larger and heavier particles with definite gravitational drop may produce better buildup. For flat and horizontal prod and yoke technique, dry powder is often used for local tests that are comparatively large size. Dry method is also superior to wet method for detecting discontinuities lying wholly below the surface. And for higher temperatures up to 600 degrees centigrade. So that is missing here. Okay, gentlemen, we'll stop here.